Hello, everybody. Welcome. We have now our session starting about how to optimize your custom ABAP code. Thank you for coming. Let me introduce myself. My name is Carlos Machado. I work as developer in the ABAP core team. Today, I'm here also with our colleague Felix, and we are here together with you just to go through this small journey about 1 hour, how to explore what is new in the ABAP world, what has been developed since the last year. What we have for our agenda today, covering this topic, so how to optimize your custom ABAP code towards HANA direction. In our agenda, we would like just to start with an overview and cover topics related with ABAP SQL and ABAP SQL windowing. What is new and how can we work with that? How can we make our code better using such technologies? Together with that, we would like to introduce also the usage of hierarchies in CDS world and ABAP world. And finally, we would like to explore what is new about the data types in ABAP. We have some samples. We will try to make it as practical as possible, so enjoy it. One rule, let's start. We have some pillars that we would like to define. We are playing with these icons. So in terms of technology, we would like to clarify 3 points or 3 pillars. So here on the left side, we would like to represent with this small icon here. I hope everybody can see. These will represent for us the coding in the CDS world, or what is happening in the data dictionary. In other words, that means that we will represent such objects globally in our system. In the middle icon, on the middle representation, we have the ABAP SQL. So this means we are coding it in our report or in our class that we would like to work with. And such objects then, at the end, they will be local objects. And finally, we have the third group that represents our AMDP, so the ABAP Managed Database Procedures. They are also ABAP objects, but they have some particularities. They are executed directly at HANA level, so they handle SQL script code. So that's our 3 pillars, and we will make them, or we will separate them with using these icons during the presentation. That's good. So let's start. Point 1. What is new in ABAP SQL world? We can make nowadays the usage of inline declarations or host expressions. What we are looking for, we would like to define and declare these variables or field symbols at operand positions. So that means we don't want in our code to have type definition, variable definition, and then we assign values to them. Translating that to the practical terms, we can see such select as a sample. We can write here, or we can select it from any table, apply any condition, but at the end, we can use this inline declarator together with this SQL execution or SQL statement. Here we see the add data and the variable name. This variable name will receive then the type that's defined as result set for this operation. Here it's a simple example. It's the time and the name. So both columns, they will be represented in this object, and they will be available in our coding. There is another variation also that we can use, the new statement. So we have the same SQL, but we have here the new add data, dumps today. So we have, again, the same variable, call it dumps today. And here we are defining the same type. However, it's a reference type. It can be also accessed in our coding. However, we will see it as declaring a variable like typeref2data. So we can propagate it in a more generic way. So that's the difference between these 2 guys. Both of them, they can be used, and they will represent exactly the result set that we have from the SQL statement. We can also make usage about the host expressions. And here we can see a sample with the modify statement. Now we are modifying this table T100. And then from table, instead of using another internal table predefined in our code previously, we can make access or just write such sample that we will define value, and then we create this variable, or we fulfill this variable directly in the statement. Such approach, it is a variable, but it cannot be directly reused because it does not exist to other parts of our coding if you would like to access it. It belongs to this modify statement itself. It's a good way to make like a clean code approach or to implement that in our world. On top, we have here that belongs to the ABAP SQL. So all this part, they belong to our middle group so far. So evolving on this perspective, we have a new topic. That's the Common Table Expression, or well known as CTE. What are they? They are the temporary definition about a result set inside the SQL statement. So that means we will have some select statement that we will define temporary views that we can play with or handle them in line to make our code easy or just readable better, or just to read it better, to simplify our code. So here we have a sample. How it works. It belongs now to the ABAP syntax. That's OK. But here we can see some particularities. That's the new approach. Here we are defining a common table expression. And this is exactly how they look like. So below this point, we can see also that we have the main select. And that is the idea. We would like to define views or temporary views that we would like to reuse inside our select statement. So how is the syntax? How I can work with this object? So here, some particularities. It starts with the statement with. And the name of the object must start with the plus sign, as we can see here. We have plus vehicles. That's just one sample. We can create more than one per statement. That's OK. It's up to us to define how much we need. After that, we can define the interface, how this object would look like. It's not mandatory. It's obviously the result set that we would like to select, but it can be explicit definition, as here. And after that, then we have the full statement, the full SQL that we can, the ABAP SQL that will represent this view. Inside the SQL, then we will have this alias or this object, this local view, we can call that, and this object can be reused inside this select statement. So here we have, for example, the definition of the object. We have as a second point the usage of the CTE inside another CTE. So we are stacking such objects. And at the end, we are just consuming this object, select from plus vehicles, and doing some joins and some rules and grouping what we need to represent in our business. So at the end, we will return again a result set, following the rules that we are applying here. When defining this object, we can make the usage also of all functionalities that we have in the ABAP SQL. For example, union all, distinct counts, or whatever, it's required also for this business. It's almost a view definition that we have in the sense of making it public. Here we have it local. There is also the possibility to use it, to use variables or to mix it with some ABAP variables. So here we have just some samples. They are constants or they are literals being extracted from the context. That can be also other variables or simply a definition that will be part of the SQL. So during the generation, this object will represent such values as well. Joins, it's another sample. We can play and fully integrate all possibilities in the ABAP SQL world into this concept. That's good. But with that, it also opened some doors to play a little bit more with this spectrum in the ABAP SQL. And here we bring the windowing part. The windowing part, then, we would like to define or just divide data subsets into our data definition. It's our set that we would like to analyze or to result or to have as result. So how it works? Let's start first with one sample. Here's our case. We have a simple data model where we have the order item, category, and price. Such elements, then, we would like to play with them. We would like to aggregate them and put this data together and apply some semantics on them. So, for example, we can extract how much each item inside one order represents as total. So we can use the windowing to extract, for example, here, just we are representing the total. In order 1, we have total of 3,500. But how can we do that inside one select just to provide us this overview, how this data behaves or how we manipulate this data together? So here we have just one sample. So the result would be 20%, 9%, and 71 for order 1. As order 2, we have just one item, means the item will represent and have just 100%. So how it works in the ABAP SQL world? Here we have one sample of this select statement. Select stay still the same, but we add some features and some keywords that can be applied and generate this result for us. So here, it's important to define. We can see that we select from the table, and we apply that an alias. Then we have the fields, and then we have the sum. So this sum, it's a normal aggregation. So we could group by and apply our order definition. However, here, this sum is followed by the overstatement. So it means that I would like to apply this specific rule to this sum. And here we are saying sum price. So we are aggregating this attribute. And over that, I would like to make it per order. So this means aggregate this information per order. That will provide us this subset inside the first selection. And with that, we are generating a field that here is called percentage. With this number, we will have the 3,500 as total, for example, for order 1. And we are dividing this constant value. So the price is divided for this constant value in this select statement. So we are able to generate exactly this number as result. But we also can play and combine grouping with windowing. For example, and of course, that will make our code a little bit complex. But let's start with the first sample. We have the orders, we have the categories for the products, and we have the prices. If we group them per order and category, we will have this subset. So order 1, we have laptop in total of 1,000, and desktop in total of 2,500. And order 2, just one item. But then we would like to represent how much each category represents inside this order. So in order 1 and order 2. So here we have the expected result. Good. How it will look like. In the ABAP SQL world, then, we will have here the select statement. And we will have, again, our sum price. So we are adding and combining this result. That's good. But this guy, now in this context, it represents to the normal grouping. So we can see there that there is group by order category. That's good. So this is our rule that we are applying. But also, we would like to apply some windowing, because I would like to filter it and represent inside the same order. So here, we have this outer sum. So we have the sum of the sum. What does this mean? This outer sum, now it is related to the over statement, as we can see here. And then we apply our second rule. So the partition here is the order. But this order is the result set of the first group by. And with that, we are able to combine these operations into one SQL statement. So at the end, we will have exactly the result that we see here in the right side. Good. Combining this also, we just talked about the CT objects or common table expressions. We can combine them. We can do whatever we want with these results. And here, we can explore the definition of this group by. That's OK. It generates us this alias, the category. So we are applying the group. We are doing a normal sum. So it is just the first grouping or generating like an intermediate result. And over this result, we can apply several functions that they are available in this windowing approach. For example, here, we are extracting the ranking. So I would like to see what is the top, or you define the sorting, could be what is the best or what's the worst item in this order, for example. This is exactly what we are doing here. So we are applying the function ranking, which will provide us the result. In sorting this, what is the top 1, top 2, top 3, inside the order, and the partition is still partition by order, and we apply some order by. Here we are doing the descending. So laptop represents 29%, so it's not the top one item, but in this logic, in this semantic, it represents a ranking number 1. So it's the least sold item inside this order. With these functions here, we have just a small list of them, and we have a sample that we can just see now. Let's first go to the sample. I would like to switch. And let's go here. So let me clean this. So we are using just the ADT, and we have a small sample that we are playing with some functions about these SQLs. For example, here we are extracting, I can show just the lag function. Let's execute this guy just to see the result. There are some functions when playing with the windowing also that allow us to go to navigate to the next line or to navigate to the previous line. So here we are using the function lag. So this means that we are navigating to the previous line of each record that we have. So let's go through this guy just quickly. We are defining a CT, call it category, and we are just doing the group by sales order plus category. So we are generating this intermediate state. And then we do the ranking, selecting from this group by here, and then ranking normally. So we'll have the sequence 1, 2, 3 for the generated objects. And here we are extracting the previous value for the line where I am at the moment. So here we can see, for example, we are extracting the sum, and sum represents the total price. We can see the total price is 27,000. And then when we go to the next line, we can have access to this 27,000. And then we can do some, we can do some operations. In this context, we are just calculating the difference between the next field, the field that comes previously to this record where we are accessing at the moment. So we are able to extract some additional information. And here, for example, the ranked result that we have, as explained it, just a sequential ordering and sorting about these items following the rule. This is the lag function. We can explore also the lead function. Just a second, it's here. So it's another sample where we are accessing now. We can, F9, let's execute it. And we can access these guys now using the function lead. Means instead of going to the previous record, I would like to go to the next record. So that's what we are trying to represent here. We can do also, we can apply some rules to it. But for example, here we have the same rule, the same definition. We do the category, and then we try to apply the rank, extracting the data from this intermediate state. We do the ranking, and here we do the lead. The lead, then, we will have the total price, again, the 27,000. And in this line, I'm able to access what comes next. So 18,500, it's available here, and we can compute some differences or apply the semantics that is necessary here. Going back to the presentation. So here we have just a list of possible functions. We will not cover all of them here. That can be explored in the hands-on session. And then we can have here the rank and the dense rank. Just one point, the rank is that it may contain gaps in case of you have some equal numbers. So this means you have twice 10 means you have no second place. Both they are the first place. And lead and lag that we just discussed. So that's the functionality, and that's the overall that we have in terms of windowing in the ABAP SQL world. Now going to hierarchies. How can I use and define hierarchies in the ABAP world, or the modern ABAP today? So definition of hierarchies. Here, hierarchies arrange data set with self-association into a tree model. That's the concept that we need to define here. They can be applied in ABAP SQL, but also in the CDS world. So this means I can play with them and define locally or globally. That's the definition and what the business requires. So how they work? Let's start with the sample. Here we have this bill of materials. In our case is, I have material and we're using a car. So every car needs tires, and every tire needs screws. That's so far. Then we need to define how these objects they are linked together, and we can apply some attributes. Here, quantity. So we have to have one car, we need to define 4 tires. And the tire has parent car. The screw, I need to attach the tire. And for each tire, I need 5. And so on and so on. We can define this hierarchy. So here, that's our sample. How it will work then if we go and we try to represent it in a CDS world. Remember, CDS world, we are creating objects in the data dictionary level. So here is the syntax that we can see. And here it states our self-association. That's important to have because the hierarchy that we are generating, it will provide us the result set exactly as I am. So I am the item 1, and item 2 will look like myself. And together with this definition, we apply the rule, we will have also the exposure, because I need to access this data. If we do the same definition now in the ABAP SQL world, means we are defining that in our local program. So here states again the variation of the syntax, and we can see we are defining a common table expression for this statement with the addition of the keyword with associations. So here join to 1, and we apply again our rule, our definition about the self-association. After that, we need to define the hierarchy rule. So continuing the ABAP SQL definition, we will see here the hierarchy, we extract from the source, and then we point to the association rule. What makes my definition? In this case, we are using this association, and the association contains the rule where or on in this context, and apply field A equals field 2. In this case, material and parent. And then we can say start where, which node will be the first one, where the parent is initial. That's good. Taking the same definition again to the CDS world, we will have a total similar statement, but this definition will belong to this data dictionary object, the CDS itself. So here we have the source, we have the association that defines the rule, and we have the starting point. Here we have also the addition how I would like to sort the siblings that belongs to this tree that will be generated. This statement is available in both ABAP SQL or CDS. After that, after this definition and making this hierarchy, then we need simply to expose it and make available. Now we need to consume it. So here is the syntax. With hierarchy, and then I say where this hierarchy is, and then I say the associations if I would like to have access to that information. Here, at first, we have the SQL definition, and then we'll have how it works in the CDS world. It's totally similar, but the principle is the same for both. After that, we have everything exposed, everything defined. So now we are able to consume it and see the result. So here we have just a sample with then this demo about this bill of material. We are defining the hierarchy, we are exposing it, and finally we are able to access it. Here we will have all this information, all these details related to the objects. And now, let's see how it works. We would like, for example, here is the boom of materials, so let me clean it. And let's execute the sample. So here, then we are able to see what is generated from this definition. And we are able also to, when we generate hierarchies, we will have some fields and some information that they will be available for us, and we can use it to define and access this data later. For example, here we have the level. So in which level this definition is generated, or what's the tree level that is where this object is. And being more realistic, or bringing this more to a real sample, in this problem, then we would like to see, for example, we have now a hierarchy defined. That's good. But now we would like to see, OK, I would like to understand how many screws do I need to produce a car. I have the hierarchy, I have the rules, everything is there. So we can make usage of some specific functions. And here we have one sample, function hierarchy ancestors aggregate. Everything is defined. So here we are saying, starting from this hierarchy plus hierarchy, which is our common table expression. I would like to see where car is the parent, or that's the final node. I would like to sum the quantity produced by these lines generated where material equals screw. So in this context, then, if we do the math here together, will be 20. But then this statement produces, and let's go back again to the sample, produces here. Let's execute this guy. We will have then this result generated automatically, just following this scenario and the definition that we have represented in these objects. Just to rephrase again, here we will see it twice. We are covering here. This is the CDS definition, means this is a global definition, and here is the ABAP generation. So this is the statement that generates the ABAP part, and the CDS, it is here. So we see that our source is not present here, but it belongs to another definition, which is a public object, and here it is. Okay. So let's return here. And just to mention again, this is the list of functions that they are available in ABAP or CDS world that can be used to generate such results and traverse the generated structure that is generated over these objects. That's good. So, finally, we arrive in our new data types in the ABAP world. With the time, we need to introduce and adjust the ABAP to handle some new types that they are now represented as primary or predefined types available in the ABAP language. They can be used in the ABAP SQL and data dictionary or the CDS world, as we discussed. Who they are? Who are they? So first, we have the definition about this DEC float 16 and DEC float 34. These objects, they are the floating point representation with 16 places or 34 places. So far, that means they are supporting the ABAP and data dictionary worlds. Together with that, we can represent now timestamps. And the field name or the type name is the UTC long. So with this type, we are able to represent then date and time together in the ABAP representation and work with it in ABAP or CDS data dictionary as well. And finally, we have the definition of date and time. Date and time, it already exists in ABAP. We all know there is the classic format. But here, we would like to say that there is a new variation that's called dat-in und team-in. This means that now we are able to represent at database level the real date and time type. So this means that in the ABAP, nothing changed, but then we will see that the database will represent with this type, which will allow us to use then other features or simplify the adaptation and the adjustment of the custom code or any implementation that's required with this adoption. And finally, we have the geometric data, which is represented with the type, and type name is GeoM_EWBK. So this type here, we are able now to represent in the ABAP world some geographical, geospatial points or polygons or any shape that we would like to represent. Point that is important here to say that the ABAP type is a binary format, so it's our X string. How they look like? So let's see them in the ABAP SQL. Those types, they are there, we can use them, and we can put them and define as normal ABAP types. The consumption for them, as usual. So we can just define them and consume it from a select or whatever we need. But then when retrieving the data, we would see some variations of this information. Here we have just a small sample, and we have the airport information. We define it DEC float 34, DEC float 16. Good. This new type .in and the UTC long that represents here our change log. So we see that DEC float 34 and DEC float 16, they are the same. They are just a number, a large point, a large floating point number. .in database side represents a real date type, in the ABAP is still the same. So we are still operating a date representation. And the UTC long now, as you can see, will represent date and time together. So it's just one field, a long field present here, and we can operate also with this type. When we do the select, we will see something similar to this sample that we are seeing here. Together with these new types, we also have some functions that we need to play with. These functions, they are date functions or conversions. So the date functions, we can use them both in ABAP and CDS. So we can operate or just consume them. The date functions, they are more clear. For example, here, days between or add days or add months. We have some date representation and would like to do something with that. That's the functions that we can use directly in ABAP or in the SQL statement. Then we have some conversions. These conversions, they are, we can say, more for internal usage. But what happens is that some functions, they depend on a predefined type. So in case we start to play with the classic date and time and the new date and time, might be that it's necessary to use such functions to convert the type to be accepted to the next function. We will see a sample later on. Time conversion is the same. I convert the classic type to the new type, and also vice versa. And finally, the timestamp, UTC functions. So here we can see what is the current UTC, or seconds between, add seconds, when we would like just to see what is in a specific range of information, for example. Again, ABAP SQL and CDS roles. How they look like? Here we have a sample, consuming them inside a CDS role. And here we can see, for example, one function, days between. Inside days between, in the second sample, we can use, again, this conversion function. In this context, we are using some intentionally mixed types to force the conversion necessity. That is the meaning or the internal usage that can be consumed with such functions. But the documentation represents each parameter that we need to fulfill, and the usage of them, it is plain as part of the SQL and ABAP roles. That's good. So, moving forward and reaching our GEO Spatial format in ABAP roles. This is applied now to both pillars, or these three pillars that we have defined: ABAP SQL, CDS, and AMDP as well. Who are they? These objects, they already exist in the HANA and other databases as well. But in the ABAP role, then it's a new definition, a new representation that's available to us to consume the geospatial point representation. So we can play, for example, with latitude and longitude together and just play with these numbers. For us, we know it represents now this GOM_EWKB type. That's our representation of it, and can be consumed in the CDS and the SQL and AMDPs as well. We will see it now. Before continuing that, let's just make a detour and see what is an AMDP, just in the conceptual words. That's important for the HANA adoption as well. We are coding ABAP, so we can take full usage and full advantage of HANA capabilities. That's good. But for that, we need some specific definitions. And one of these specific definitions, it's the AMDP world. At the end, it's just an ABAP class. But it has some particularities, because we would like to push down this execution to the HANA level. So we are not writing entirely in ABAP anymore. We are writing in the SQL script, or the HANA native language, to represent this execution. With that, we are looking to explore all possibilities in HANA, all engines, and geospatial engine in HANA is one of these possibilities. There are some points that it's important to keep or to be aware of, that the restrictions. It's database specific, it's HANA only, and there is no fallback in case of database change. It's supported so far, then only for HANA. So, what are they at the end? They are stored procedures that they will be represented in the ABAP world, and the execution, the runtime, will be executed directly at database level. Means we are coding now in SQL script. So far, so good. This approach, it's important to say that when we mix it with the CDS world, this means that there are some variants of the CDS object. They are called the table functions definition, that they depend on CDS, or the CDS table definition, they depend on AMDP. So that's the combination. Now we are making the AMDP available to the ABAP through this CDS table definition object. But again, it's all HANA runtime. Debugging goes through HANA, that's the point. So how they look like? They are an ABAP class, that's all. But there are some particularities, and one particularity here is this interface. It's mandatory to import this interface and say, oh, hello, I am an AMDP. And with that, I would like to represent AMDP methods. Here, it's one sample of a generic method definition. We can use as normal, import, export, or changing parameters with default values, yes or no. That's, again, the semantics definition. OK. Default value. And we need also to take care, after that, about a specific signature for this method implementation. So here states, then, the specific keyword or syntax that we need to use by database procedure for HDB language SQL script. That will allow us then to write in this method only SQL script code or SQL script code. And here we can see everything that comes next, it's basically HANA language. That's all. There are some variations, for example, that we can guarantee, OK, nobody touched my data, I'm accessing it, but it's read-only. That also helps us to extract, for example, parallelization also from HANA side. It's just to speed up the operation. And one characteristic, we must explicitly say which tables we would like to use. So here, we are just using one table. That's one AMDP. That's what an AMDP is. So now we are able to go back to our GEO Spatial Data. With that, we can create then tables, for example, with this type. It's a normal ABAP type. However, it has a specific point that we need to add the semantics together. We are representing now coordinates or points in our planet. That's the idea. And with that, we need to say which spatial reference system we are using. By default, we are using this 4326. That's a global convention, and that represents the same system that mostly all GPSs they use. So we are saying that this field is linked with this kind of coordinate system. That's good. So now it's part of our data dictionary. And after that, we create a table, we have data, and we can select on the table. It's a normal field. So far, so good. However, this field, when we retrieve it to ABAP world, that means we will see some binary information. It's not readable for us, and we are not looking to read that information. This is the representation in ABAP, how this geographic type will look like. To operate with that, we need AMDPs, because we need to push this down to HANA. So, starting with our AMDP definition. Here we will define a return structure. Again, just the point. We need a type, and we need also the semantics. Means the annotation for the spatial reference system. 4326. Good. After that, we can use this object now inside our AMDP object. And here we are representing them. We are using the interface. Yeah. Then we are consuming this type, which we have already defined with this referential system. And then we can operate here using HANA functions. So for example, the problematic here, the sample is, I have now, let's go to the samples, I have now a definition or a model where I am defining states. And in these states, so just here the AMDP, so here we have our sample. And these states, they have their format. So let's say that they are a square. And there is one table. Let's access the table just to see the data. So where we represent our states. So the data, just accessing it again, you see there is one ID, the state name, and the boundary. This number, again, can represent 1 point, or like 1 square, 1 circle, 1 polygon, whatever this state represents. But what we are looking is, OK, I have a list of customers. And then I can ask, which customer belongs to each state, or which customer is part of a radius of 100 kilometers? This is the rule that we would like to apply. And in this sample that we have here, we are using this function that is boundary st covers that will say which customers belong to that state, and we apply the rule. For example, who I have never make any order item or any order to this customer. At the end, let's execute this operation. We can extract only what covers this area that we are looking for. So this is the mix about the AMDP and the new types that we have in ABAP. So in this case, we are using the geographical representation about this, this kind of problem that we have defined. The consumption of it, so here just stating a function, and the consumption of this AMDP at the end is exactly one single call for this method. It's a class, it is there, we have just defined it, but everything has been executed inside HANA. That's good. That's good. So, with that, we reached the end of the content that we have. Thank you very much for attending, and I think we can open for questions. I think we have some mics running around. Yeah.
Are these features available with SAP HANA, or do you also need S4?
These features that we have explored here, they are part of the ABAP. So they come mostly with ABAP 7.5 so far, and you can consume it by ABAP definition. In this case, for example, of the AMDP definition, you are open to consume everything that the HANA version that you are running offers. There is no limitation. So all functions, all engines, they are there, and they are able to be consumed. OK. We have another question here.
If you want to validate your code, any new tools or something available?
Sorry?
If you want to validate or do runtime analysis on your code, or validate statements, any tools?
When we talk about this mixing, for example, AMDP, mixing SQL world and SQL script, it is already validated. So when we compile and define these functions, they are validated directly with the activation.
I meant runtime analysis. So
yes, and also the profiling with the ADT, there is a possibility to run it measuring what happens inside HANA. So it's exactly as the ABAP profiling, but we are measuring the AMDP itself, what happens inside. So for example, you are doing joins, unions, or calling another AMDPs or another HANA functions, then you will be able also to profile that and understand what is happening.
Thank you.
To complement also, the result of that is you will be able to understand what's happening in HANA. And any optimization needs to be done on the SQL code.
Is it possible to debug the SQL script in the AMDPs?
Yes, it's integrated also with ADT, and you can set breakpoints as a normal ABAP coding, and it will be available for debugging. There are some slight differences. For example, when debugging, you cannot step into. There are the famous F6, F5, F6, F7, F8. They don't work, all of them, for this debugging in AMDP. But you can set the breakpoints and navigate with F8 until the next breakpoint, for example. So we'll be able to read variables, what is happening, where I'm going through. So it works, and it needs to be done via this ABAP development tool or these Eclipse plugins. Debugging. So thank you again.